So I'm giving you one example here. Okay, I'm starting with an example. And we'll check whether the given solution is a buffer or is not a buffer. So very carefully observe this example. HF. There are 20 moles of HF. I'm not giving you molarity, I'm giving you moles. 20 moles of HF mixed with 30 moles of NaOH. Is it a buffer? Sanjana? Sanjana is new here. Azuni, Nivriti. Sanjana, other children will join the class. And like today, I think there is some exam in USA. Few of my students, they inform me that there is some exam. So few of them are not turning up today. Okay, Nivriti, this is Sanjana here. Now look at this solution. Now Sanjana, we are doing buffers, and we started it in the last class. Right now, I'm just discussing some examples to identify whether the given solution is a buffer or not a buffer. Okay, Sanjana, you have any background of the buffers? Sanjana, do you have any background of the buffers? You know something about buffers?
I know that it buffer is created with like a weak acid and strong base.
No, 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 no.
Mhm.
Buffers are created by weak acid and its salt. And its salt. Like HF is a weak acid or strong acid? Sanjana, you have to type here in the chat. Okay, now try to understand this and keep asking your questions. Okay, Sanjana? So HF is a, oh, no direct message, Sanjana. Journal addressing to everyone. So HF is a weak acid or strong acid, children? This HF is a weak acid or strong acid? Remember, only three non-oxo strong acids. Afan, only three non-oxo strong acids are HCl, HBr, HI. Sanjana, memorize this. These are the only three strong non-oxo acid. Non-oxo. Now then, what is HF? HF is a, yes, please answer. Nivriti, Azuni, what is HF? Strong acid, weak acid. This line I'm telling you from last so many classes that these are the only three strong acids without oxygen. Without oxygen. With oxygen, do you know the names with oxygen? Strong acids with oxygen? HNO3. Yes, sir. Afan, very good. HNO3, HClO4, HClO3. It's very important that you should know strong acids to learn this buffer. Only then you can say, oh, this is a weak acid. These are oxygen containing non-acids, oxo acids, which are strong. These are strong. Strong. Sanjana, write down this part. This is very important, very important. Don't do error in this. It's very important to know, to identify your important strong acids and strong bases. So HF is a strong acid, children, or weak acid? What is it? HF is a weak acid. I'm writing here weak acid. What about NaOH? Yes, NaOH. Is it a strong base or weak base? NaOH is a strong base or weak base? NaOH is a strong base. Okay, very good. So who is going to tell me what all are strong bases? I told you only these are strong bases. Rest all bases are weak. This I was telling you in the last class also. Strong bases. Yes. Who's going to tell us? Afan? Strong bases? Yes, Ashlisha. Very good. See the line given by Ashlisha? Calcium, strontium, and barium. Ashlisha. Calcium, strontium, and barium. Group 1, calcium, strontium, and barium. These are the strong bases. Okay. Now, Sanjana, you know group 1 metal hydroxides? What do you think, Sanjana? KOH. Is it a strong base or weak base? KOH. And what do you think for MgOH twice? Strong, weak? This one. Mm-hmm. These are the only one which are strong. Is magnesium there? Is magnesium there, Sanjana? Yes, children, what do you think? MgOH twice, strong or weak? Yeah, it is weak. You just memorize this. These are the strong bases, then this is weak. So MgOH twice is weak. So we need to identify our strong acids, strong bases, weak acids, weak bases to learn buffers. Yes, Nivriti, good. Okay, so HF is a weak acid and NaOH is a strong base. So they are going to react. They will react to give you complete the equation. This you remember these questions we did in the last class. All the question we did. Now complete this equation, children. Double displacement, acid base reaction, hydrogen is plus, F is minus, Na plus, OH minus. What's the product? Yes, Sanjana, try it. H plus will go to, yes, Afan. H plus will go to OH minus. Na plus will go to F minus. So what's the product? Very good, Azuni. H2O plus NaF. Yes, very good, Sanjana. Okay, now is it balanced? Equation is balanced. Every equation, when you're writing the equation, the next question in your mind should be, is it balanced? Only then you start doing something. Don't do anything before checking whether the equation is balanced or unbalanced. Okay, now let's talk about initial. How many moles of HF are given? 20. How many moles of NaOH are given? 30. Initially, water is 0, NaF is 0. Finally, now they are reacting. So you have to check. 20 moles of HF can react with 20 moles of NaOH. 1 is to 1, right? 1 is to 1. So after the reaction, how much HF is left? After the reaction, finally, how much HF is left, children? 0. Very good, Slisha. How much NaOH? Yes, Sanjana, good. How much NaOH? Azuni? 20 will react with 20. Yes, who is this? Sanjana, very good. Water. How much water formed? 20 will give you 20. Yes, very good. How much NaF? 20. Now, Ariba, check. In the final equation, in this final, do you have this HF? Is HF there? 0. Is NaF there? Yes, 20. Is it a buffer? Children, is it a buffer? No, it's not a buffer because there is NaF and there is NaOH. So we have a salt and we have a base, strong base. It's not a buffer. Is it clear to all of you? It's not a buffer. So there is a weak acid, there is a strong base, but you cannot say without calculating. Right now I calculated, I said, okay, it's not a buffer. Some students will say, why she is checking this? She can say from here only. A weak acid, strong base is not a buffer. No, no, no. See here, I'm changing the values. I'm changing the mathematics here. I'm giving you 10 of this. Now this is 10. Now your finals are changed. Can you give me the finals now? Finals are changed. 1 is reacting with 1. This 10 will react with 10. So finally, how much HF? Yes, very good. Perfect, Sanjana. How much NaOH? Azuni, why 0? Azuni, what are you giving me? Aslesha, Azuni, you are giving me NaOH? Okay, good. That is 0. How much water formed? Yes, good, Azuni. How much water? 10. How much NaF? 10. Check the final solution. Do I have HF in the final solution? Yes. Do I have its salt? It's salt. HF and its salt. And NaF is its salt. With common ion. Remember last class we were discussing the mechanism? 10. Water, of course, water is also there, but water is the part of the system. So, is it a buffer? Yes, it is a buffer. So, understand that whenever there is a weak acid and a strong base, straight away don't say that it's not a buffer. Check the composition finally. Check the final situation after the reaction. Okay, this is very important. Can I give you one more last question based on it? Okay, one last question based on the same concept that I'll give you some composition and you are going to decide whether it's a buffer or not. And you are not going to decide just by looking at it. You'll check the reaction. NH3, 2 molar, mixed with 5 molar hydrochloric acid. So first, let's write on the reaction. So what's the reaction, children? NH3 is a base or acid? You know, ammonia, I told you make it as your best friend. So this NH3 is a base or acid? Yes, Sanjana, it's a base. Very good. Nivriti, base. Sanjana is new, children. Yeah, very good. It's a base. Ammonia is a weak. Is a weak base or strong base? Remember, strong bases are already written here. It's a weak base. Very good. It's a weak base. Perfect, Sanjana. So, ammonia is a weak base and HCl is a strong acid. I will check the reaction. Who is going to complete it? Base takes a proton. What's the product? This base will take this proton and it becomes ammonium chloride. Yes. So you can write it like this, the way Azuni is writing. Ammonium. Very good, Azuni. Aqueous. Afan, no answers today? Afan, start answering. Good. Okay. Now, initially, what's the concentration of ammonia? 2 molar. These are, this is 5 molar. These are together in the mixture in 1 liter. HCl is 5 molar. How much ammonium initially before the reaction started? 0. Cl minus 0. Finally, who is going to be 0? Ammonia is? Ammonia is? Yes, Sanjana is writing already. Very good, Azuni. Ariba, your understanding? HCl is? Yes, 3. Ammonium is? 2. Cl minus is? Yeah, 2. Okay, good. So is it a buffer? Check finally what all is there. Do you have the weak base? Do you have ammonia? Ammonia is 0. HCl is 3. Ammonium is 2. So we have HCl and we have the conjugate acid. This is the conjugate acid, children. Conjugate acid of ammonia, right? So ammonia with this conjugate acid. So here right now I have acid with acid, acid with acid, no buffer. Afan, do you agree with me? No buffer. Acid with acid, no buffer. I'm changing the composition, children. I'm making this 2 ammonia as 8. Let's do the changes. 8. Now the finals will change. Can you complete the final? Give me in one line. Give me here, what should I place here? Give me everything in one line. I'm waiting for your answer for all of you. Aslisha is very fast. Sanjana, good. Sanjana is giving you good competition, children. Perfect, Azuni. Ariba? Okay, who else is not answering? Nivriti, where are you, dear? Okay, good. So you can see that this is 3, 0, and then you said this is 5 and 5. So finally, look at the finally. Do you have ammonia finally? Yes. Do you have this strong acid? No. Do you have this ammonium? Yes. And chloride, of course, yes. Ammonia with ammonium is a buffer. So is this solution a buffer? Afan, is this solution a buffer? Yes, it's a buffer. Good, very good. Okay. So that's the meaning. These type of questions can be there. And I don't think they are difficult. You have to understand the chemistry, you have to see the reaction, and after the reaction, you have to see whether that final condition of a weak acid with a salt or weak base with a salt, whether that is fulfilled. If it is fulfilled, means if it you have a weak acid with a salt or a weak base with a salt, then it's a buffer. Otherwise, no. One last question. HCN with KCN, is it a buffer? HBr with KBr, is it a buffer? HCN with KCN, yes or no? So identify HCN. Is it a strong acid or weak acid? You remember all carbon containing acids are very good, Aslisha. All carbon containing acids are weak acid. This is a weak acid. This one. And this KCN is a salt. Is salt. So is it a buffer? Yes, children, answer it fast. Sanjana, yes, good. It's a buffer. Why? Because there is a weak acid with the salt. HBr and KBr, is it a buffer? Why not, Eslisha? You're right, but why not? Azuni, you're right. Why not, Sanjana? Give me the reason. Because HBr is a strong acid and KBr is salt. There is no weak acid or weak base, so it cannot be a buffer. Ammonia with NaOH, is it a buffer? Yes, Nivriti, very good. Ammonia with NaOH, is it a buffer? Anil, you're not answering anything. Anil, no, it's not a buffer. Okay, give me the reason why. Do you think they will react with each other? Afan, do you think they will react? Should I do that reaction and check? What is ammonia? Afan, no, very good. They will not react. No reaction because both of them are bases. And base is not going to react with another base. So there is no question of buffer. So that's the identification. Okay. Now the next thing is how to calculate the pH of a buffer. Okay, they say that they will not ask you to calculate, means there will be no question in which they will be asking you to calculate the pH uh, of a buffer after adding something. Normally we'll calculate if I give you a buffer and I say calculate the pH, so that question can be there. But in the buffer, some base is added, some acid is added, that question will not be there. So how to calculate the pH of a buffer? We are going to use Henderson Hasselbach equation. You can see the name here, Henderson Hasselbach equation. We are going to use this equation. Now, what is this equation and how we have to understand this equation and use this equation? So we'll practice few questions on it. Okay, I'm taking a weak acid, HA. So this HA will dissociate in water to give. Can you complete the equation, children? HA is dissociating in water to give. Yes, it's an acid, weak acid. There is an equilibrium. Very good, Afan. H plus aqueous and A minus aqueous. Okay. Now you write down Ka expression for this. Yes, what is the Ka expression? A means Ka. What's the meaning of Ka? Yes, acid dissociation constant. It's an acid dissociation constant, equilibrium constant for the dissociation of an acid. It's an equilibrium constant, right? Called as acid dissociation constant. What's the expression? Yes. Yes, Ariba, you're there? Yeah, only Sanjana is answering. What about rest of you? You don't remember this expression? Very good, Sanjana. HA. This is Ka. Very good, Azuni. Ariba, you remember this equation? Aslisha, Ariba, Nivriti. Okay, now let's do one thing. Okay, all of you are okay with this equation? Good. Take negative log of this equation, negative log. Then it becomes negative log of Ka is equal to negative log of H plus. This multiplication will become plus and then negative log of concentration of A minus over HA. This one. Are you okay with this? Now, what is this negative log of K called as? See, this derivation is not the part of your study. I'm just showing you this derivation just to make you familiar with this Henderson Hasselbach equation. Yes, very good. This is pKa. What's the negative log of H plus? Yes, Afan? pH. Very good. Very good. And I'm going to keep this plus. And I'm going to take this minus inside over here. I'm going to invert the ratio. So it will become log. Okay. hmm I'm going to take it as such. Sorry. Take it as such. Don't invert. So this plus minus will become minus log concentration of A minus over concentration of HA. Rearrange this equation in terms of pH. When I'm going to rearrange it, it will become pH equals to pKa plus log concentration of A minus over concentration of HA. This is your Henderson-Hasselbalch equation. This is the pH of the buffer. This equation I'm going to use on a buffer, not on normal acid and base. We use it on the buffer. So this is the pH of the buffer. pK, you know, if K is given, you can calculate pK. What is A minus, children? What is A minus? A minus is the concentration of conjugate base, isn't it? This is the conjugate base, A minus. Conjugate base of the weak acid. And what is HA? It is the concentration of weak acid. This is Henderson-Hasselbalch equation. Sanjana, you are aware of some uh, mathematical operations of the logarithm? Okay, good, very good. Now let's do one thing. Okay, look at this equation and answer my questions, all of you. If the concentration of conjugate base is equal to the concentration of weak acid, what's the what's the value of pH? What's the relation between pH and pK? If these two are equal, you know that log 1 is Sanjana 0. If these two are equal, then it becomes log 1. Then pH equals to, yes, Azuni? Very good, Afan. Perfect. See? And in the last class, you remember, I was discussing the role of the conjugate base and weak acid in controlling the pH in the buffer action. So this is the best buffer. We call it as best buffer condition. You will understand this why. This is the best buffer condition. So a solution is best buffer when the pH is very close to pKa. Okay. Now, this is first condition. Second condition. If the concentration of conjugate base is more than concentration of weak acid, then this pH will be greater than pKa or less than pKa. If the conjugate base is, this conjugate base is more than weak acid. Think like this. Then the concentration of conjugate base over the concentration of weak acid is greater than 1. So the log of this value, if I take the log of this conjugate base with weak acid, will be a positive value, right? It will be a positive value, greater than 0, you can say. It will be greater than 0. If it is greater than 0, then pH is greater than pK. Are we okay with this? Sanjana, you're understanding this? Azuni, Ariba, Ariba, is it okay? Nivriti, if it is okay with all of you, I'm going to give you third condition and I'm not going to solve it. You people are going to solve it and you're going to discuss everything with me. Ready? I'm writing this is first, this is second, I'm writing third condition here. In the third condition, we are using Henderson Hasselbach equation. The concentration of the conjugate base is less than the concentration of weak acid. So it means concentration of conjugate base over concentration of weak acid is less than 1 or more than 1. This ratio is less than 1 or more than 1, is less than 1. Then what does it mean? If it is less than 1, the log value will be positive value or negative value? Log value. Log value of less than 1 is always, you check, you have calculators, take logarithm of 0.01. Check the logarithm of 0.1 or 0.01. Yes, it's negative log value. This you should know. I'm going to trouble you with this thing in unit 9. Log, if the value is, if the ratio is less than 1, logarithm of less than 1 is a negative value. Negative means it is less than 0, correct? Then in that case, pH, yes, Azuni, very good. pH is less than pK. Nivriti, Nivriti, are you there? You're understanding these three conditions, children? 1, 2, 3. Oh, Nivriti is not in the class. Hmm. Okay, fine. So this is your Henderson Hasselbalch equation. This is how you have to work out your pH of the buffer system. Without calculation, you can easily predict whether the pH will be more than pKa or less than pKa. This equation is valid for acidic buffers. Acidic buffers means a weak acid with its conjugate base. What's the equation for a basic buffer? Let's see the equation for a basic buffer. I'm going to erase this. Shall I clear this? Now let's take a weak base, base B. Let's write down the dissociation of this base, weak base, so there is an equilibrium. Remember I told you whenever you are taking a base without hydroxide, you have to use water to complete the equation. You are not going to write without water. Okay, what's the product? Complete the equation. Yes, children, complete the equation. Mhm. Yes, children, complete the equation. Yes, Sanjana, there is error in the charges. Is this plus you have written on B? Azuni, you are also aware of it. BH plus plus OH minus. Base is going to take hydrogen from water. Yes, Ariba, good. This is important. You know, this is something in which most of the children are doing error. Okay, fine. Now let's write down Ka or Kb? Kb, the base dissociation constant. It is the concentration of Hb plus times concentration of OH minus over concentration of B. This water is liquid, so it's not the part of the equilibrium. Now take negative log of this complete equation. Negative log of Kb is pKb. Negative log of OH minus is negative log of OH minus POH. Very good. Negative log of the rest of the thing here. So it is negative log of the conjugate acid over the weak base. Rearrange this equation. Rearrange it for POH. So POH is pKb plus log concentration of Hb plus over B. You know, this is the equation for basic buffer. Basic. Buffers can be basic, buffers can be acidic. This is basic buffer. And what is the equation for acidic buffer? Acidic buffer. Yes. That equation will be given to you in the formula sheet. pH equals to pKa plus log. What should be in the numerator? The conjugate base. A minus over, yes, Sanjana, Afan, good, over He. Perfect. Yes, Asuni, perfect, good. So now equation is clear. This equation derivation AP is not asking. The way I'm deriving here is showing you everything. I'm doing all these things to make you more and more familiar with the equation. You should understand everything. What is pKb? pKb is negative log of Kb. See, negative log of Kb. So that is the reason I derived it. Now we are going to use it. Application. Ready for a question, children? Okay, this we have discussed. The same thing I was discussing with you. Okay, yes. Can you calculate the pH of, is it a buffer? First you check. What kind of acid is this? Weak acid or strong acid? Remember the term? I used a word, all carbon containing acids are weak acids. So it's a weak acid. Out of these two hydrogen, which hydrogen is acidic? This also I told you last time. Which hydrogen? The hydrogen bonded to carbon or the hydrogen bonded to oxygen? Sanjana, hydrogen bonded to oxygen, not to the carbon. Yes, Azuni. Because this oxygen is more electronegative. So this hydrogen is acidic. In oxo acids, children, do you remember in oxo acids, I told you that the acidic hydrogen is always on the oxygen. Sanjana is saying first one because generally we say acids always start with hydrogen, but this is an organic acid, Sanjana. It's an organic acid. Otherwise, if I say HNO3, so children, this hydrogen is bonded to nitrogen or oxygen? In HNO3 Nivriti, this hydrogen is bonded to nitrogen or oxygen? Yes, anyone? What I said here, Nivriti and Sanjana, what I said here. Okay, what's the meaning of this? That in oxygen containing acids, hydrogen, acidic hydrogen is always on the oxygen. And then just after writing this, I'm asking, is this hydrogen bonded to nitrogen or oxygen? Yes, Nivriti. Azuni, now you must be wondering why. I can show you the Lewis dot structure. I made it last time also. This is the Lewis dot structure of your NO3. In fact, HNO3. In fact, in all the oxygen containing acids, though it is written first, but actually it is bonded to oxygen. See, where is the hydrogen? Here, H2SO4. Is this hydrogen bonded to sulfur or oxygen? There is a plus here on the nitrogen. Is this hydrogen, these Lewis dot structures can be in the exam. So please practice them. These hydrogens, yes, Afan, these hydrogens are on the oxygen or on the sulfur? Nivriti, hydrogens are on the oxygen or sulfur? Aslisha and Azuni, correct yourself. Aslisha, correct. It's always on the oxygen. I'm writing here. Then why you're saying it is on the hydrogen? By convention, we write them first, but they are on the oxygen. Check the Lewis dot structure. This is the Lewis dot structure of sulfuric acid. Remember, I discussed the strength of oxo acids. Then we were saying, okay, oxygen, hydrogen is always on the oxygen, so this bond length is constant. So we are not going to discuss anything from here. We'll discuss the central element, sulfur. Yes, Afan. See what Afan is writing, children. Can you write down this in your notes? What he has written? He's giving you a sentence which you can write down in your notebook. That in oxygen containing acids, acidic hydrogen is always on the oxygen. So back to the question. This is a weak acid. What is this? What is the conjugate base of this weak acid? Write down the conjugate base. Remove this hydrogen. The conjugate base is Aslisha, you are removing wrong hydrogen. See how Azuni has written? Yes, good. This hydrogen is acidic, right? In organic acids, it's an organic acid, carbon containing. So in organic oxo acids, we can write acidic hydrogen in the last also. This is one of the option. Okay. So this is the conjugate base. So we have a weak acid HCOOH and we have its conjugate base HCOO minus K plus, right? Is it a buffer, children? Yes, it's a buffer. Can I use Henderson equation? Yes, I can use Henderson equation to know the pH. So pH equals to pKa, Ka will be given to you, plus log concentration of what should be in the numerator? HCOO minus what is there in the denominator? HCOOH. So, do you know pKa? Take the negative log of this. Negative log of this. Did I tell you this mathematical shortcut for taking negative log of these kind of numbers. If I take negative log of this 10 raised to power minus 4 will come in front as 4, and it is left like this: 4 minus log 2.4. You can write it like this: 4 minus log 2.4. Otherwise, you can use your calculator. So the pK will be slightly less than 4. How much is this, children? Anyone doing calculations? You will go for two significant figures, and it is 3.62. Very good. 3.62. Two significant figures, Sanjana. This number has 2, this number has 2. In pH, POH, pK, wherever you are using this P or logarithm, the first number is due to exponential, this exponential. This 3 is due to this. So it's not the part of sig fig. I think this I told you last time also. Okay. Now plug in this concentration. How much is that? This one. 0.52 divided by 0.30, and that's the pH of the buffer. Is it okay? Can you see that how you're using Henderson equation to calculate the pH of the buffer? Go for two significant figures only after decimal. So I'm going for two significant figures after decimal because this is pH. First number is not counted. Before decimal, these numbers are not counted. 3.86. Yeah, I'm also getting this. Azuni, can you check? Azuni, can you see? I think you have taken this ratio wrong, Azuni. If you see, this number is this concentration HCOO minus the conjugate base is more than concentration of HCOH. So this number is greater than 1. So this log value will be a positive value. This positive when added to 3.62, it becomes this. So these type of questions will be very simple. You have to just use your Henderson Hasselbach equation. Ready for another question? How much we were getting? Okay. See, they are using some other pK value. Our pK value was different. Maybe they have taken some other Ka value, slightly different from this one. But I've taken this one. So that's why the answer is slightly changing. So you have to take the Ka value given to you in the question. Ready for this question? This one. HNO2 is this. You can see its Ka value. HNO2, is it a strong acid, weak acid? HNO2. Remember, I gave you 4 important oxygen containing strong acids. Is HNO2 there? 4 important oxygen containing strong acids: HNO3, H2SO4, HClO4, HClO3. Is this HNO2 there? No, it's a weak acid. It's called as nitrous acid. All acids ending with us, nitrous, they are weak acids, all of them. Okay. And NaNO2, NaNO2, you can see that it is the salt of this acid. So is it a buffer? This system is a buffer? Yes, it's a buffer. You can use Henderson equation. pH equals to pKa. What's the pKa? Mhm. Get the value of pK. You can see the Ka value. Shall I write here? The Ka of this acid is 4.0 times 10 raised to power minus 4. So what's the pKa? Yeah, yes. Who is this? Azuni. Perfect Azuni. I'm also doing the same thing. I generally do like this. The way Azuni is writing, children, it's very easy. 4 minus log 4. So answer will be 3.40. Yes, Sanjana. 3 point. Okay, Nibriti and Afan, you are not helping us in calculations. Ariba, 3.40 plus log. What should come in the numerator? These concentrations are given. Log. What should be in the numerator? NaNO2 or HNO2? The concentration of the conjugate base, NO2 minus. Yes, NaNO2. How much is that? Yes, Azuni, how much is that? 1.00. And how much is HNO2? Same, 1.00. What's the pH? Log 1 is always 0. pH equals to pKa. pH equals to pKa. Very good. And if pH equals to pKa, Afan, then what kind of base is this? Everything. What kind of buffer? When pH equals to pKa, it is the best buffer. Means it has very high tendency of controlling any acid or any base. It can control both of them equally. It can kill an acid when you add a drop of acid, immediately the conjugate base will react with it. If you put a drop of base, immediately the weak acid will react with it. It's the best buffer. Okay, we are done with this question. Can you try the next one? HF. Is it a weak acid or strong acid? Please write, all of you. Can you give me three non-oxo? Non-oxo means without oxygen. Three non-oxo strong acids. Can you type the formula of three non-oxo strong acids? Okay, Aslisha, very good. HBr. And Azuni is giving all of them all together. Yes, Afan, Azuni. These are the only three. These are the only three which are strong. Rest all are weak. So HF is weak. If I give you H2S, is it strong or weak? It's also non-oxo. Is it strong or weak? Yes, children, it's weak. Okay, HF is a weak acid. KF is a salt. It's salt. Weak acid with this, you can say is conjugate. You can say common ion. You can say is salt. It's conjugate. It's salt. Or there is common ion. You can say anything here. These are more popular word. And this is the one which I was using in the last class to explain you how this buffer system is working. The mechanism of buffer or the action of buffer is based on this. So can I use Henderson? And you can see this is here. K is given. So Ka for HF is 7.2 times 10 raised to power minus 4. Now let's use Henderson. pH equals to pKa. What's the pKa, Azuni? Can you write in the same way as you were writing earlier? Azuni, write it in the same way. Children, see how she is writing. That's very easy method. You can plug in very easily in your calculator. Yes, like this. So if you plug in like this in your calculator, you will get 3.14 plus log concentration of. So whose concentration will come in the numerator and whose concentration will go in the denominator? There is Kf and there is Hf. Can you tell me what should I plug in here? And what should I plug in here? Because if we do error here, yes, Azuni, very good. How much is Kf? How much is Kf? 1.00. Is this value going to be greater than 1 or less than 1? If it is greater than 1, this will remain positive, right? And pH will be greater than pKa, right? Okay. What's the answer? What's the pH? 4.81. Okay. Sanjana is giving us 4.81 children. Is it correct? And you can see that 4.81 is definitely greater than 3.14. Yeah. Yes, that's what I was thinking. 3.14 and this ratio, I don't think is such a big jump, Sanjana. Can you check your calculation again? Yes, I'm also getting 3.36. Sanjana, check your calculations. 3.36. That's the pH. What about rest of you? So this is how we are going to work about the pH of the buffers by using Henderson Hasselbach equation. So ready for next topic now? Oh, okay, no problem. So ready for next topic, children? Okay. Next is, now we are done with the buffers. I think buffers is clear how to calculate the pH by using Henderson equation. Henderson equation is clear to us. This is Henderson equation, this one. You can, if you can see mouse or this one, this is Henderson equation. The same equation in base for the basic pH buffer will be POH equals to pKb plus log concentration of the conjugate acid over concentration of the base. Like for example, if I say there is a buffer of ammonia with ammonium. So it's a basic buffer. Ammonia is a base, ammonium is conjugate acid. If ammonia is 0.10 molar and ammonium is 0.01 molar, how this relation will hold? Will the pOH greater than pKb or less than pKb? Can you answer this? Yes, Azuni, perfect. Very good. So pOH will be greater than pKb or less than pKb? Can you check who is more? Ammonia is more. Ammonium is less. This number will become less than 1. Less than 1 means this answer will be negative and your POH will be less than PKB, and only Azuni is answering. What about rest of you? Afan? After that, I'm taking you now on the next topic. This is buffer type questions, Henderson equation, identify the buffer. If the conjugate base is more than the acid, then pH will be greater than pKa. If it is less than the acid, all these questions, multiple choice questions. Okay, so now we are going on the next topic, acid acid base properties of salts. So first of all, what are salts? During acid base reaction, a salt is formed with water. Water is there if you are dealing with hydroxides, then water is there. So it's not necessary that every time water will be there, but in general, we say an acid reacts with a base to give a salt. This is compulsory with water. And now this water can be formed, it cannot be formed. It is formed only if you are using a metal hydroxide as a base. Like for example, if I say I'm using HNO3 acid, this hydrogen is on the oxygen, and a base ammonia. If I'm using HNO3 acid and a base NaOH, can you make the product here? Like here, what's the product? There will be no water in this case because you're using ammonia, you're not using a hydroxide, right? Yes. So Azuni, I can write it like this, like a salt, ammonium with 1 plus, nitrate with 1 minus. So I can write it like this. And there is no water. See here, no water. No, no, that's perfectly all right what you are writing. Nothing wrong in that. Because if I'm working with water, all these are working in water. Then this ammonium nitrate is completely soluble in water, is 100% dissociated the way Azuni is writing. It's completely dissociated. But right now I'm just writing it like this to make you understand the meaning of the salts. Can you complete this equation, children? This one. Can you complete this equation? Mhm. The hydrogen of the acid will react with OH minus to give. Yes, Sanjana, very good. NaNO3 plus water. Very good, Sanjana. Very good. Yes, Ashlisha, perfect. Okay, so now here a water is formed. Can you see the water? Why? Because this hydroxide, metal hydroxide, the base, the OH minus, will react with this H plus to form water. So whenever you are using hydroxide as a base with acid, this is a compulsory product, right? Okay, now how this reaction can give you the salt, that is clear to you. Now I'm reversing the equation. I will give you a salt and you have to identify the acid and bases which can be used to get that salt. My question is getting reversed. Ready? So what I'm saying that there is a salt, NaF, this salt. Can you tell me which acid reacts with which base to give you this salt? Can you identify acid and base here? And always remember the positive, the cation of the salt. Salts are, there is a cation, there is an anion, right? Cation is always coming from the base, and anion is always coming from the acid. So identify what is the cation here? Na plus F minus. So can you identify the base which can give you Na plus? Base of Na, base with Na. Mhm. Can you identify the acid with F minus? Yes, Afan. Think fast. Anyone? What happened? It's very easy. No, no, dear Afan. NaNO3 is not a base. Base are metal hydroxides. Remember? NaOH. And this is right, HF. So when you add NaOH in HF, what's the product? NaF and H2O. So can I call this salt NaF? NaF. Can I call it a salt of what kind of base is this? Of strong base with what kind of acid is this? Acid. Yes. Can I call it? This is a salt of strong base with weak acid. Now the next question which I'm going to place here, all of you are going to answer. Question will be like this only, the way we have done this. This time I'm giving you KNO2. Can you identify from where I'm getting this K plus? This is K plus, cation, this is NO2 minus. Can you identify from where are you getting this K plus and this NO2 minus? So what acid and base I should take so that I can get KNO2? The way we have done this one. So K plus is coming from cations are coming from base. Yeah, which base? Sanjana, K plus with base. Which base? Bases, metal. Yes, it is KOH. Very good. KOH. And NO2 minus is coming from acid. Which acid? Just this is minus. Put one hydrogen in front of it. HNO2. And this KOH is a strong base or weak base? It's a strong base. HNO2 is a strong acid or weak acid? It's a weak acid. So this KNO2, this one, can I say it's a salt of strong base with weak acid? Can I say that? Okay, now few of you are not answering. Aslesha, are you okay with this? Ariba, you're okay with this? Aslesha, okay. Nivriti, last question. Try to answer. I'm going to erase everything now. I'm going to give you a salt. You have to identify the acid and base from which you can get this salt. ammonium sulfate. So this is the ammonium is the cation and this is sulfate. Do you know the charge on sulfate, children? Charge on sulfate. What is the charge on sulfate? Yes, 2 minus. Yes, very good. It's in sulfuric acid also. Perfect, Sanjana, again. Okay, now tell me from where you're getting this ammonium. Who is giving you ammonium after the reaction? Hmm? Ammonium is the cation. So identify the base. Yeah, base. Which base? There is only and only one important base, one important friend, ammonia, isn't it, Azuni? Ammonia is a weak base. Weak base. Can you identify which acid can this acid, the sulfate, which acid? Yes, that is H2SO4. Is this strong or weak, children? Very good, Sanjana. Nivriti, is this a strong acid or weak acid? H2SO4. I gave you only 4 strong oxo acids. Oh dear, Azuni. Oh, Nivriti. No, 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 no. Of course, if it is not weak, then strong. There are only 2 options. If I'm saying no for weak, then it's strong. Okay, all of you, please type 4 important strong oxo acids. Afan, I know you know it very well. 4 important strong acids, oxygen containing. Hmm. And Azuni is very fast. So, children, see what she is writing. Nitric acid, perchloric acid, chloric acid, and sulfuric acid. Afan, where are you? You're not answering? Okay, good. So, remember that few things we have to memorize, but memorizing is not like sitting and memorizing. Memorizing is practicing. So, whenever I'm asking, try to type all the formulas. This is how we memorize by practicing, not by just sitting and memorizing. That will not help you. Okay, now we have understood the meaning of the salts. Now I'm going to identify them as acidic and basic salt. Children, do you remember a strong acid will give you a weak conjugate base? You remember that? A weak acid will give you a strong conjugate base. A strong base will give you a strong base will give you weak conjugate acid. A weak base will give you strong conjugate acid. And you also remember that whoever is strong, whoever is strong is going to control the pH of the solution. Just write on this. Like, for example, if there is a fight going on, whoever is stronger, a stronger fighter, is the winner, right? So, whoever is going to be stronger in the solution, this is acid based solutions. Whoever is stronger is going to control the pH of the solution, right? Stronger controls the pH. Write down this line. During titration, we are going to discuss this more in detail. I'll say, okay, who is controlling the pH here? So immediately you'll identify who is stronger here. Oh, this is controlling. If base is controlling, pH is more than 7. If acid is controlling, pH is less than 7, like this. And this is one thing. Second thing is, when I say strong conjugate base and strong conjugate acid, it doesn't mean that they are very strong. It doesn't mean that they are 100% dissociated and very, very strong. It means these are just stronger than water. They are stronger than water. So we are going to understand these lines now, these two lines. Ready? So I'm giving you NaF, right? Now this NaF has come from, what's the base? What's the acid? Can you identify? Mhm. This NaF is going to dissociate as Na plus aqueous and F minus aqueous. Can you tell me from where I'm getting this Na plus? Na plus, the base? Tell me the base, Afan. Very fast. Which base is going to give you Na plus? Ariba? Yes, so why you people are taking so much time? Is it a strong base? Okay, strong base. If it is a strong base, is it strong or weak? Na plus. Na plus is coming from, it's a weak conjugate acid. Ignore it. It's very weak. It's not going to do anything. It's just a spectator, just there helping in neutralizing the charges of the solution. That's it. Nothing else. It's not going to trouble water. It's not going to react with anyone. It's lying there as spectator. Is it okay? Because it's weak, right? Can you identify from where I'm getting F, this F minus? Mm-hmm. Is it strong acid or weak acid? It's a weak acid. If it is weak acid, then F minus. Strong what? Afan. Strong conjugate base. And what this strong conjugate base is going to do, Afan? Now finally, I have a strong conjugate base. Who is going to control the pH? Who is going to control the pH? The strong conjugate base. And it's a base. So pH will be more than 7. You're understanding this? When you put this salt in water and you calculate the pH of that solution, pH will be more than 7. Why? Because you are getting a strong conjugate base. This one. So what? The strong conjugate base F minus is stronger than water. So it's going to react with water. Stronger, they react. So the strong conjugate base is going to react with water to form. Can you complete the equation? F minus is a base here. So water will behave like an acid. It's going to force water to behave like an acid. What's the product? Azuni. Perfect. Very good. Excellent, my dear. And you're getting OH minus. Formation of OH minus in the equation means pH is more than 7. These two lines are clear now. Whoever is stronger, you said this is a strong conjugate base. If you are getting a strong conjugate base, your salt is basic. Now, this strong conjugate base is stronger than water, means it's going to force water to behave like an acid. So, it's a base, it's an acid, you are getting OH minus. If you are getting OH minus, pH is more than 7. Any question here? If it is clear to you, can I give one question from my side? Are you ready for a question, everything? Miss Lesha, ready for question? Okay, good. I hope you have written these lines. Follow them, okay? Just you're going to search who is stronger here, and accordingly you will decide. Okay, I'm giving you a salt here, and the salt is CH3. I need a glass of water, so I'll take only few minutes, not more than 1 or 2. By the time you decide about this salt. Okay, so you decided the base here and the acid here. Mm-hmm. You decided the base? No, 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 dear. The base is CH3NH2. Yes, Azuni. You remove the hydrogen, remove H plus from this part. Remove H plus to get the, because this is the conjugate acid of that base, right? Aslesha, Nivriti, the base is this. Is it okay? And what's the acid? Add H plus. Yes. What kind of base is this? Afan, what kind of base? Oh, Azuni is already telling us that this is a strong acid. But this base, you already know your strong bases, right? Is this in that list? That list was given by Aslesha in the starting of the class. It's a weak base, yes. You remember Aslesha was writing 2 lines. She wrote 2 lines in the chat. In 2 lines, she was giving us all these strong bases. It's a weak base. Okay, now let's see. Now you're going to identify. When I'm going to put this compound in water, it's going to dissociate. It's going to dissociate to give you CH3 NH3 plus Cl minus. Now, this is the weak base. So, what kind of conjugate acid? Conjugate acid. Weak base will give you strong conjugate acid. And Cl minus is weak conjugate base. Who will control the pH of water? So, the pH will be less than 7 or more than 7. Strong conjugate acid is less than 7. Very good. So this salt is acidic or basic? This salt is acidic or basic? It is acidic. Acidic. Prove it. They can ask any question. They will ask you to show it. Show that is acidic. So you take your strong conjugate acid CH3NH3 plus. It's very strong. not fully 100% dissociated. Very strong means it's stronger than water. So what is going to do? It's going to behave like an acid in water. If it behaves like an acid in water, it will force water to behave like a base and then set up the equilibrium. Write on the products. This is the acid, this is the base. So acid will get converted into its conjugate base. Remove H plus. And water will get converted into its conjugate acid. Yes, children, complete the equation. Remove H plus from here, add H plus here. Yes, Azuni is giving us the equation. Azuni, no minus. It's already plus, right? So when you remove H plus, no charge left. Plus H3O plus. What are you getting? You are getting H3O plus. Sanjana, very good. You are getting H3O plus in the solution. And if we are getting H3O plus in the solution, means pH is less than 7. Means in that water there are more hydronium than hydroxide. In that solution, hydroniums are more because they are getting formed. So they are more than hydroxides. So is the meaning of acidic and basic salts clear? Okay, great. Now, this sometime when you are going to learn more about, when you are going to read from the book, you will read a line there. Hydrolysis of salt. Hydrolysis of salts. This line is there. What does it mean? Means if there is a strong conjugate base, it will force water to behave like an acid. This reaction of the conjugates with the water is called as hydrolysis. Hydrolysis means reaction with water, right? Strong conjugate base will make water acid. Your strong conjugate acid will force water to behave like a base. So these reaction which you are doing here, these type of reaction, this is hydrolysis. It's the reaction with water. Hydrolysis is a very popular term in organic chemistry also. Hydrolysis means reaction with, reaction with, yes, Afan, reaction with, Afan, you are listening? Reaction with what? With water. Yes, Sanjana, good. Good, Afan. Perfect. So these are the reactions with water. The salt. This is the salt, this salt. In this salt, when it's going to split, it's going to generate this, but this one is going to react with water. So hydrolysis is reaction with water. Let's try to understand one more salt, KNO3. Can you identify from which acid base you are getting K plus and from which you are getting NO3 minus? And I'm going to place it in water and it's going to dissociate completely as K plus aqueous and NO3 minus aqueous. Yes, K plus from, yes, all of you please, Aslisha, Ariba. K plus from KOH. Is it a strong base or weak base? Yeah. So its conjugate is weak conjugate acid, this K plus, right? Let's check NO3 minus. This one. Identify from which compound you are getting it. NO3 minus. Mhm. Yes, NO3 minus, children. It's an anion, HNO3. Is this HNO3 a strong acid or weak acid? HNO3, yes, strong, weak. It's a strong acid. So what is this? What is this? A weak conjugate base. A weak conjugate acid, a weak conjugate base. Who is going to control the pH? Who is controlling the pH of this solution? Who is stronger here then? These are weak. Who is stronger? Somebody is stronger. Stronger than these two. Who? Water. Water, Azuni, there is no HNO3. HNO3 is not there. Do I have HNO3, Azuni? There is no HNO3. I'm talking about this solution. I'm talking about this solution. I'm not talking about this. This we are trying to understand the nature of K plus and NO3 minus. So these are not there. So when you have a weak conjugate acid from a strong base, a weak conjugate base from a strong acid, both of them are weak. Then pH is controlled by stronger water. Water is stronger than them. So water controls the pH, right? Water controls the pH. So what's the pH of this solution? Yes, and the salt is called as neutral salt. Neutral salt. So write down this. Make this table, children. If I take a strong acid and a strong base, if I take this, then pH will be 7. And we are going to call it as neutral salt. And in this case, who is controlling the pH? Because their conjugates are weak. So who is controlling the pH? Water. Water will control the pH. But if I give you a strong acid with weak base, now whose conjugate is stronger? Conjugate of the strong acid or conjugate of the weak base? So that conjugate is strong conjugate acid. Okay, Aslisha. That conjugate is stronger. If it is stronger, it's an acid, right? So pH will be less than 7. And who is controlling it? The strong conjugate acid of weak base. Of weak base. And we are going to call that salt as acidic. And if I give you a weak acid with strong base, whose conjugate is stronger? The weak acid. But its conjugate is a base, right? So pH will be more than 7 and it is controlled by a strong conjugate base of weak acid. And it is basic. One more question, children. If both of them are weak, weak acid and weak base, both of them are weak, but Ka is greater than Kb. Ka is greater than Kb. It means the base is more weaker than acid. So whose conjugate is more stronger? So what will be the pH? Because this is a base, its conjugate is an acid. So pH will be less than 7. And it is controlled by strong conjugate acid of weak base. The base is more weaker. Write on this. Okay, now answer this. So this is condition 1, 2, 3. This is 4. Now I'm writing condition 5, children. 5. Again, weak acid. Both of them are weak. Weak acid with weak base. Here, Ka is less than Kb. So who is more weaker? Who is more weaker? Only Sanjana and Azuni are answering. What about rest of you? Afan, Nivriti, Ariba. Why you are not answering? Acid is more weaker. So who has more stronger conjugate? Weak acid. And what is the conjugate of weak acid? What is the conjugate of weak acid? Is it a acid or a base? So it's a strong conjugate base. So that's the one who is going to control the pH. So pH will be more than 7 or less than 7. Yes, Azuni. Very fast. Very good. More than 7. It is because of the strong conjugate base of weak acid. This salt is acidic and this salt is basic. One last condition for this, and then we are going to discuss some questions. Last condition. I'm writing here, sixth one. If there is a weak acid with weak base, the salt is of a weak acid with weak base, but their Ka is, the K of the weak acid is nearly equal to Kb. Then who is going to control the pH? So they are of equal strength. Water, yes, and the pH will be nearly 7. So is this acid-base properties of salt clear? Aslesha, you're back. Nivriti, you're not answering. Nivriti, Ariba, are you there? Both of you? Nivriti, yeah, it is a neutral salt. Yes. Azuni is a neutral salt. Nivriti, you are understanding everything because you're not answering anything. Ariba, you're understanding everything? So why you're not answering, dear? See, rest all are typing very fast, answering. I'm sure they are making notes also. So ready for questions now? Okay, let's do questions. First question you can see here. You have to start from most acidic. Who is most acidic here? Yes, HCl. And you have to go to the most basic. Who is most basic? Yes, on this end there is KOH. Now these are salts. Now you have to identify them as neutral salt, acidic salt, basic salt. Ready? Check this one. KNO3. I think we just did it. So identify. K has come from, NO3 has come from, K has come from strong base, KOH. NO3 has come from strong acid, HNO3. Strong base, strong acid, their conjugates are weak. So the pH is controlled by water and the pH is 7. So KNO3 is neutral. Place it in the center. It's a neutral salt, children. A strong acid with a strong base, the conjugates of both of them are very weak. So water is only the one who is stronger there, and water pH is 7. Okay, now let's work with KCN. KCN. K has come from, CN has come from. Can you identify? We are working with KCN now. K has come from KOH. KOH is strong base. CN minus has come from Aslesha, you're back. Ariba, CN minus. Nivriti, HCN. Yes, children. What about you? Nivriti, you are not answering anything. Okay. HCN is a weak acid or strong acid? Okay, fine. Come back fast. HCN is strong or weak? It's a weak acid. So, whose conjugate is stronger? This one. So, CN minus is a strong conjugate base. So, what kind of salt is this? Acidic or basic? Again, Azuni, yes, it's your basic salt because Cn minus is a strong conjugate base. It will generate OH minus in water. So I'll write KCN here. It's a basic salt. Let's work with ammonium chloride. Ammonium chloride. Ammonium. Yes. What is the base here? Ammonia. Chloride. HCl. So what kind of salt is this? Whose conjugate is stronger? Is ammonia weak? Yes, ammonium. Yeah, ammonium is stronger. But that's the conjugate acid. So the conjugate acid is stronger. So what kind of salt is this? Acidic, basic, or neutral? It's acidic, so I'm going to put it here. This is the order, children. This is a base, strong acid. This is neutral salt. This is basic salt. This is acidic salt. This is how we are going to work and try to take out the answer. Only Sanjana and Azuni are answering. What about rest of you? Because I'm worried. Have you understood this? Because it's slightly not difficult. You need to focus what I'm teaching. If you are not focused, then you won't be able to catch it. Nivriti, good, Afan. Aslesha, you are back? No, she's not back yet. Okay, Nivriti, what is acidic need? I'm not asking that question. Nivriti, you are listening. I hope you are listening. I didn't ask anything. I said, are you understanding? See, children, you have to stay focused what I'm teaching. Those who are answering here, I know that they are focused because they are answering whatever I'm asking, they're answering. For rest, I have to call the name 2, 3 times and then you are answering. That's not good. Nivriti, no, no, it's not going to work. In the starting of the class, Nivriti, you were listening and you are answering very accurately. You remember? But this part, acid base properties, particularly this question, I didn't see any answer from you, Ariba, Afan. Only Azuni and Sanjana were answering. Now focus here. Okay, let's do one more question. Nivriti and Ariba, you are with me? Let's do this one. pH is 8.02. What kind of salt is this? Acidic, basic, or neutral? Answer every question, Ariba and Afan. What kind of salt is this when the pH is 8.02? pH is 8 fast. Answer fast, Ariba. pH is 8.02. Is this an acidic salt or basic salt or neutral salt? Very good. It's a basic salt. Very good. Basic. pH is more than 7. Now they are asking which salt is this? Is it NaOCl or NaCl? So what kind of salt is this? Can you identify the base here? Nivriti and Ariba, can you identify the base here and the acid here? Okay, Nivriti has already answered it. Very good, Nivriti. Very, very good. Perfect. She's saying the salt is this. Can you answer why? Because this OCl minus is the strong conjugate base of this weak acid. This is hypochlorous acid, and this is a strong base already. Yes, yes. Nivriti, perfect. I know you know the answer. I know that you're understanding, but keep answering here, okay? What about NaCl, Ariba? NaCl? Ariba, you're not answering. NaCl. Na plus has come from NaOH, and Cl minus has come from HCl. So, what kind of salt is this? Is it acidic, basic, or neutral? Is anyone giving you anything strong? Sanjana is right again. It's a neutral salt. Why? Because you are using a strong base with strong acid. Perfect. So the answer for the first question is NaOCl. Now, when the pH is 6.3, we are working with the next question, this question. Is it an acidic buffer or acidic solution or basic solution? pH is 6.3, acidic or basic? It is acidic. Perfect, acidic. Okay, good. Now the salts given to me are ammonium chloride and K plus with C2H3O2 minus. Okay, identify the base and acid. Yeah, okay. She's seeing ammonia and hydrochloric acid. Very good, Azuni. So what kind of salt is this? Whose conjugate is stronger? Conjugate of ammonia is stronger. That is ammonium. This ammonium, is it a conjugate acid or conjugate base? Yes, ammonium. Yes, children, ammonia you know is a base. So this is a strong conjugate acid. This is a weak base. So this salt is acidic, basic, or neutral? Yes, Nivriti, good. This is acidic. Perfect, Nivriti. Acidic. So it means it can be this salt. This is acidic. We decided this is acidic. What about this one? This one. This has come from KOH. This has come from C2H3O2 minus. And if I remove this minus, it's an acid like OH. You know, this you can see in the exam like this also. CH3COOH. This is again a very important acid and we call it as acetic acid. Acetic acid. If you see the polyatomic ion list, there you can see this ion C2H3O2 minus as acetate. It's an acetate. and you put hydrogen in front, like this can be written like this also, right? It's an acetic acid. What kind of acid is this? Strong or weak? This one. Is it a strong acid or weak acid, children? It's a weak acid. Then this conjugate is strong conjugate base. Then this salt is basic salt. pH will be more than 7. Okay, so that's the acid base properties. That's the understanding of how these acids and bases salts are reacting with water. So now let's do this question. These type of question we have already done. This particular salt we have already done. Anyone, can you recall and can you answer straight away without troubling my brain? Straight away. Is it acidic, basic, or neutral? Just work out in your notebook. Check the base, check the acid, check whether they are strong or weak. See who is giving you stronger conjugate. Decide the pH and identify. Waiting for the answer for the A part. Mhm. Very good. Neutral. Who is this? Slasha. Neutral. Yes. All of you agree with her? Sanjana, you agree with her? Yes, good. Okay. Check the B part. Again, Slasha. Very good. What about rest of you? It's a salt of weak acid. I gave you the table. From there you can identify. It's a salt of weak acid. So NO2 minus is a strong conjugate base. So basic. Ariba, are you getting basic for this one? Nivriti, Ariba? Okay, next one. Mhm. This is the anion. This is the cation. Identify. Identify. Yes, acidic. Perfect. Acidic. C is acidic. Okay, next. Okay, this is weak base. This is weak acid. Use this table. This table, see? Okay, where is ammonia? They have given ammonium, this one. The Kb for ammonium, the Ka, sorry, Ka for ammonium is 5.6 times 10 raised to a minus 10. And this one they have given, this weak acid they have given as 4.0 times 10 raised to the minus 4. So who is stronger? Now this question is slightly tricky here. They have given the Ka of this ammonium. You work out the Kb of the base. You remember Ka times Kb is Kw. So what is Kb for this base for ammonia? Is 1.0 times 10 raised to power minus 14. And what is Ka for ammonium is given here, divided by 5.6 times 10 raised to a minus 10. Can you check what's the answer? It is 1.7856 you can take times 10 raised to power minus 11. So now I'm writing here Kb of the ammonia is 1.785 times 10 raised to a minus 11. So this is Kb, which is weaker than, lesser than Ka. So who is stronger? The weak base is very weak. So its conjugate is stronger. So ammonium is stronger, right? So what kind of salt is this? Remember I told you that if both of them are weak, then you just check that if Ka is greater than Kb or Ka is less than Kb. Check your table which I gave you. In that table I'm explaining everything this. So here the Kb, this Kb is less than Ka. It means the base has a stronger conjugate acid. It means the salt is acidic. Right, children? So whenever both of them are weak, then you compare their K and Kb values. Can you answer this one? Like this one is easy. K plus and OCl minus. K plus has come from KOH. OCl minus has come HOCl. Yes, answer it. And then we can end the class. This example we can do in the next class. Can you answer this? Answer this and you can leave the class. And if you have any questions, you can stay back. So identify this E as acidic, basic, or neutral. You already know KOH is Afan. KOH is, I can help you if you are finding it difficult. It's a strong base. Hypochlorous acid is a weak acid. So who is strong? Strong conjugate base. So in this KOCl, there is a strong conjugate base. So what kind of salt is KOCl? What kind of salt? So why you people are taking so much time? Is it clear? It's basic salt, right? Okay, then I'll see you tomorrow, Sunday. You have an extra class in your morning. See you. In case you have question, you can stay back. Bye.